If you're buying fleet vehicles right now without specifying bidirectional charging capability, you're locking your operation out of a revenue stream across the entire service life of those assets. For transit and school buses, that means a decade or more of foregone opportunity built into a capital decision you made on a spec sheet. So today we're decoding EV, fleet integration, and V2G, vehicle to grid. This episode is for fleet managers, facility directors, and operations executives at logistics companies, transit authorities, and municipal fleets, even manufacturing facilities running electric vehicles or planning to do it. So if your electric bill is 5, 6, or 7 figures and you operate a fleet, this episode is for you. By the end, you'll know exactly how V2G works, what it pays, which fleets are in the most, and what you need to specify in your next procurement cycle. I am Daniel Burke, and this is Energy Answers, brought to you by Tactical Energy Group. Now, here's the short version. V2G, vehicle to grid, turns your parked electric vehicles into grid assets that generate revenue while they sit idle. Your vehicle's charging during low-cost, off-peak hours, store that energy, and discharge it back to the grid when demand is high. You get paid either directly through a utility pilot program, through a demand response aggregator, or through wholesale market participation via an ISO like PJM or CAISO. The payment path depends on your service territory. The question for your operation is whether your vehicle chargers and software are configured to make that possible. And for most fleets right now, the answer, unfortunately, is no. If you caught our deep dive on battery energy storage in episode 14, you already understand how a battery behind the meter can shave peaks and interact with the grid. Today, we're taking that same concept and putting it on wheels. And if you watched episode 18 on virtual power plants, your EV fleet is one of the most dynamic assets you can add to that stack. So this is Energy Decision 25. We're going to cover what V2G is, what it pays, who it works for, and what the procurement trap looks like before you walk into it. So what is the cost problem V2G actually solves? When multiple EVs charge simultaneously at a depot, they create a demand peak, and that peak triggers utility demand charges, and demand charges often represent 30 to 50% of a fleet depot's total electricity cost. A 15-minute peak usage event can trigger charges of $15 to $35 per kW every month. Charging during peak hours costs 2 to 3 times more than off-peak rates. And if simultaneous charging exceeds your site capacity, you're looking at infrastructure upgrades of $50,000 to over $200,000. On top of that, parked vehicles are idle, capital generating nothing for you. Now, how does V2G address any of that? V2G enables bidirectional energy flow, not just grid to vehicle, but vehicle back to the grid. The operational cycle works like this. Vehicles charge overnight at low cost rates. Batteries store that electricity while the fleet is parked. The utility sends a signal indicating high demand. The V2G chargers export stored energy back to the grid. The fleet receives payment, and the system automatically recharges vehicles before the next dispatch. 3 things have to be in place, though, for this to work. First, V2G capable charging stations. These are not standard EV chargers. They enable communication between the vehicle, the charger, and back-end management software. Second, V2G compatible fleet vehicles, and at the time of writing, few V2G enabled commercial fleet vehicles were available in the market. The list is expanding, but it remains narrow. Third, V2G software that manages load balancing, dynamic billing, and dispatch response. Now, what does V2G actually pay? The revenue is a stack of 4 services. Frequency regulation. Millisecond response to grid frequency changes pays an estimated $2,000 to $5,000 per vehicle annually and is the highest value service in the stack. Peak demand shaving pays $800 to $2,000 per vehicle by reducing your own demand charges through export during peak periods. Demand response program participation pays $500 to $1,500 per vehicle. Energy arbitrage, buying low off-peak, selling high on-peak, pays $300 to $1,000 per vehicle annually. Now, these are not projections. In Beverly, Massachusetts, 3 school buses generated over $60,000 across 3 summers through National Grid's Connected Solutions program. The University of Delaware has run 15 Nissan Leafs at $2,500 to $5,000 per vehicle annually since 2013, with no significant battery degradation observed. A Colorado school district generated $12,000 in a single quarter from its V2G bus fleet. But who benefits the most? School bus fleets are the top candidate. Summer idle periods create long windows of grid availability without touching operational readiness. Revenue potential runs $5,000 to over $10,000 per bus annually. Transit buses are next at $2,000 to $5,000. Delivery fleets and municipal fleets follow. The core principle is very consistent. The longer the fleet parks, the higher the return. Now, what about battery degradation? This is a big concern. Calendar aging, time-based degradation, accounts for 85 to 90% of total battery degradation, and it happens whether the vehicle participates in V2G or not. A 2025 applied energy study found V2G adds only 9 to 14% additional degradation over a 10-year period under managed conditions. The University of Delaware 5-year deployment observed no significant degradation. LFP battery chemistry supports over 4,000 charge cycles. The marginal degradation cost of V2G is small. The marginal revenue, though, is substantial. One structural barrier to name clearly: in some territories, enrolling in a special EV time of use rate can disqualify you from certain demand response programs, meaning you have to model both paths and pick the more lucrative stack. California is the exception. The Emergency Load Reduction Program and PG&E's hourly flex pricing can be stacked simultaneously, with the operator paid on whichever is higher at any given hour. And that kind of program design is not universal, and every state has its own rules. Know what your service territory allows before you commit to a rate structure. So here's what I want you to take away from the procurement angle specifically, because this is where operators can get hurt without knowing it. The vehicles you buy today will determine your V2G eligibility across their entire service life. For transit buses and school buses, that is often a decade or more. So that's a capital decision you need to take seriously. A word of caution on vehicle lists: you'll see bidirectional capability marketed broadly, but true V2G means export to the utility grid under a utility program is a shorter list than vehicle to home or vehicle to load features that only power your buildings or devices. Several vehicles now support vehicle to home or vehicle to load, but that is not the same as utility grid export. So before you write a procurement spec, confirm with your utility and the OEM whether the vehicle and charger combination supports actual V2G under an available program in your service territory. Bidirectional capability and specifically V2G compatibility should be a procurement requirement, not an afterthought. If this is not in your spec sheet today, you're not going to benefit. Look, I don't run your fleet. That's your job. But my job is to bring you definitive answers to the most pressing energy questions facing commercial and industrial operators like you. So here's the bottom line on EV fleet integration and V2G. The technology works, the pilot data is real, and the revenue is significant, but only if the vehicles, chargers, and software are specified correctly before you buy. Operators who treat V2G as a procurement requirement today will have a structural cost and revenue advantage that compounds over the life of the vehicle. Operators who don't will spend the next decade paying demand charges on a fleet that could have been offsetting them. So here's a 4-stage sequencing framework if you're not ready for full V2G today. Stage 1, time of use optimization. Schedule charging during lowest cost off-peak periods. Stage 2, load balancing across the fleet. Peak reduction of 10 to 25%. Stage 3, demand response enrollment. Participation revenue of $500 to $1,500 per vehicle annually. Stage 4, bidirectional deployment and grid services participation, $1,000 to $5,000 per vehicle per year. Each stage builds the foundation for the next. Ask your team these questions. Does your current vehicle procurement specification require bidirectional charging capability? And have you confirmed that means true V2G, not just vehicle to home or vehicle to load. Do you know which utility programs are available in your service territory for V2G participation, whether any of your current EV rates make you ineligible for demand response? What's your fleet's average daily parking window, and have you mapped that against grid peak periods to estimate your revenue potential? And has anyone modeled the demand charge reduction your fleet could deliver through smart charging alone before a single bidirectional charger is purchased? Hey, if today's episode got you thinking about fleet electrification decisions you have in front of you, vehicle procurement, charging infrastructure, utility program enrollment, I want to help. Me and the team at Tactical Energy Group created the Energy Decision Blueprint for exactly this kind of situation. So if you're an Indiana-based commercial or industrial operation spending 5 figures or more on electricity each month, and you are in energy improvement mode, here's how this all works. We'll jump on a call together, you and I'll learn about your situation and figure out as quickly as possible if I can actually be useful to you. Now, if I can't, I'll tell you why and I'll give you your time back. But if I can, we'll pull your bills, any relevant data, interval data, proposals, pro formas, we'll crunch it and give you a full take. Whether the project is optimally structured, whether the payback will actually materialize, what alternatives you may not have considered, and where we see opportunities for you. You'll get the write-up and you're obligated to nothing. If that interests you, click the link in the description or go to tacticalenergygroup.com and look for Energy Decision Blueprint. Thank you for listening to Energy Answers, brought to you by Tactical Energy Group. If this helped, send it to another operator you know who's dealing with the same headaches, and visit tacticalenergygroup.com to get more practical tools for your facilities.